Section 8.2. Testing a claim about a proportion. In this section, we are going to test a claim about P, population proportion. The objective for this section is going to conduct a formal hypothesis test of a claim about a population proportion P. Notation: N is the sample size. P is the population proportion. P hat is the sample proportion. P hat equals to X over N. Sometimes you might have to find X. So X equals to P hat times N. And Q equals to 1 minus P. The requirement for testing a claim about population proportion. First, the sample observations are simple random sample. Second, the conditions of a binomial distribution are satisfied. There is a fixed number of trials. The trials are independent. Each trial has two categories, success and failure. The probability of success remains the same in all trials. 3. The conditions N times P is greater than or equal to 5 and N times Q is also greater than or equal to 5. Example 1. In a program designed to help patients stop smoking, 212 patients were being given sustained care and 81.1% of them were no longer smoking after 1 month. Use a 0.01 significance level to test the claim that 80% of patients who stop smoking when given the sustained care. First, I have N equals to 212 patients. P hat is 81.1%. If I want to find X, I take N times P hat. And I got 171.932. X will be whole number, so I am going to round this to the nearest whole number, which is 172. The question: use a 0.01 significance level to test the claim that 80% of patients stop smoking when given sustained care. My original claim is that 80% of patients stop smoking. I am going to do the hypothesis test. My first step is to identify the original claim. Original claims say that 80% of the patients stop smoking, so P equals to 80%. Second step is the statement when the original claim is false. If the original claim is false, that means when P equals to 0.8 is false, that is when P is not equal to 0.8. Third step is when I identify my hypothesis, HO and HA. So from these two statements from the first two steps, I take the one with no equal sign for my HA, and HO is containing the equal sign. To identify the type of test, we look at the inequality of HA. So this is not equal to, saying that this is going to be a two-tailed test. On the fourth step, we are going to identify the significance level. So I'm going to go back to my problem to see if it's given to me. Use a 0.01 significance level. My alpha is 0.01. For number 5 and 6, where I look for test statistic and p-value, I am going to use StatCrunch for these two numbers. Stat, proportion stats, one sample with summary. Number of successes is your X. 172. Number of observations is your N, 212. We are going to select the hypothesis test for P. In HO, P is equal to 0.8, and we are choosing not equal to for HA. Compute. This is my test statistic, and this is my p-value. And I get z equals to 0.41208,169. This is the z-score, so I am going to round it to 2 decimal places. However, if there is an instruction on your homework problem, please follow the instruction on how to round. And p-value, I got 0.6803. This is the probability. I am going to round it to 3 significant figures. Again, if there is an instruction on how to round, please follow the instruction. Step 7, I am going to make my decision whether or not I reject or not reject HO. In order to make your decision, all you do is comparing your p-value and your alpha. P-value is 0.680, which is greater than alpha. That means I do not reject HO. And the last step is trying to state the conclusion without technical terms. If you still need help on stating out your conclusion, please visit the chart on section 8.1. My original claim contains the equality, and I failed to reject HO. Here's the chart that helps me to restate my conclusion. Original claim includes equality, and I failed to reject my HO. There is not sufficient evidence to warrant the rejection of the claim that. And I am going to insert my original claim in here. 80% of patients stop smoking when given sustained care. Example 2. Consider a sample of 45 football games, where 28 of them were won by the home team. Use a 0.10 significance level to test the claim that the probability that the home team wins is greater than 1/2. I have n equals 45 and x is 28. They want me to use a 0.10 significance level to test the claim that the probability is greater than 1/2. My original claim is P is greater than 0.5. These are the 8 steps that I have to finish in order to do my hypothesis test. The first step is the original claim. P is greater than 0.5. Second step, if the original claim is false, that is when P is less than or equal to 0.5. For my hypothesis, from these 2 statements, the one that does not have equal sign is going to be my HA. And my HO always contains the equal sign. Significance level, I'm going to go back to my problem here. They told me to use 0.10 significance level. So alpha is 0.10. Again, if alpha is not given, always use 0.05. I am going to use StatCrunch for my test statistic and the p-value. Stat, proportion stats, 1 sample with summary. X is 28, N is 45. P is 0.5, and we are choosing greater than. This is my test statistic, and this is my p-value. For test statistic, I get z equals 1.639782. For the z-score, I'm going to round it to 2 decimal places, which is 1.64. P-value, I got 0.0501. I am going to round it to 3 significant figures, which is 0.050. To make my decision whether or not I reject my HO, I will compare my p-value and my alpha. P-value is 0.05, alpha is 0.10, so p-value is less than alpha, which means I am going to reject my HO. And to make my conclusion, again, if you're not too familiar with this, please go ahead and use the chart that we have in section 8.1. A regional claim does not include equality, and we reject HO. A regional claim does not include equality, and we reject HO. There is sufficient evidence to support the claim that from here, I am going to insert my original claim in here. The probability of the home team winning is greater than 1/2.